everybody. In this video, we will be discussing Mechanics Paper 4-2 from May-June 2022.
Before we begin, subscribe and hit the like button if you want good A-level math scores.
Question 1. So we can immediately tell that this question involves collision, and when you meet this type of question, it's always nice to draw a diagram for before and after the collision. Let's read. Small smooth spheres A and B of equal radii and of masses 5 kilograms and 3 kilograms respectively lie on a smooth horizontal plane. Initially, B is at rest, so that means U is equal to 0, and A is moving towards B with speed 8.5 meters per second. The spheres collide, and after the collision, A continues to move in the same direction, but with a quarter of the speed of B. The question asks, find the speed of B after the collision. So the speed of B is the unknown here, and we can write it down as VB, while VA is 1/4 the speed of VB, right? So to do this, we need to use the conservation of momentum equation, which is written down here. And for this, we just have to substitute the values. That is 5 times 8.5 plus 3 times 0, which is just 0 because B is not moving, equals to 5 times 1/4 VB plus 3 VB. Plugging into your calculator, the left-hand side would equal to 42.5 equals to 4.25 VB, right? Which is just 5/4 plus 3. Then you solve to find VB equals to 10 meters per second. And our answer for part A. Now on to part B. Find the loss of kinetic energy of the system due to the collision. To find the loss of KE, all we need to do is just find the KE before the collision, then the KE after the collision, and find the difference. So for the KE before the collision, it's simply the KE of A plus the KE of B using the initial conditions. By now, you should already know the kinetic energy formula, half mv squared, right? So it would be half times 5 times 8.5 squared for A and 0 for B because B is not moving. That comes out to 180.625 joules. Now for the kinetic energy after the collision, we first need to find the speed of A after the collision, which is 1/4 the speed of B. That would be 2.5, right? And plugging into the formula for kinetic energy, for A it would be half times 5 times 2.5 squared plus half times 3 times 10 squared, which comes out to be 165.625 joules. Then the kinetic energy loss would just simply be the difference between the two, and that comes out to be 15 joules, and that is your answer for part B.
Hello everyone, my name is Michael, and now I will be discussing this question number 2. Okay, coplanar force of magnitude 60 Newton, 20 Newton, 16 Newton, and 40 Newton act at a point in the direction shown in the diagram. Find the magnitude and the direction of the resultant force. Okay guys, so if we find this type of question and this type of diagram, we can actually use the formula of EFX and EFY. Okay, so what is EFX? EFX is actually the sum of the forces in the x direction. EFY is the sum of the forces in the y direction. Okay, now let's start by searching for the EFX first. First, we can simply write the 14 Newton first here. 14 plus 16 Newton will be moving in this direction, which if we see this is an adjacent and this one is hypotenuse. So if we have adjacent and hypotenuse, we will be using cos. So plus 16 cos 50 minus 20 Newton will be also going in this direction. So it will be 20 cos 60 equal to 0. So the EFX, we can simply put this in the calculator to get the answer. 16 cos 50 minus 20 cos 60. Okay, we will be having the answer of 14,285. Now, let's search for the EFY. So for the EFY, we can actually see we have the 60 Newton here, so we can write it 60 first. And now, the 60 Newton and the 20 Newton will both go in this direction. So we will be having sine 16 sine 50 minus 20 sine 60. So we can get the value of EFY by inputting also in the calculator. 60 minus 16 sine 50 minus 20 sine 60. We will be having the value of 30.423. Okay, but guys, we haven't done yet. Because why? The question asks for the resultant force, not the EFX and EFY. So how can we implement the EFX and EFY to find the resultant force? Okay guys, so actually, by drawing the diagram, EFX will be here, and EFY will be here. Okay, now, how do we find the resultant force here? To find the resultant force, actually, we could use the trigonometry function, where RF is equal to the square root of EFX square plus EFY square. So the resultant force is actually simply square root of 14.285 squared plus 30.423 squared. So if we input it in the calculator, we will be managed to get the answer. So 14.285 squared plus 30.423 squared. Okay guys, so we have found the answer of 33.61. But guys, we haven't done yet. Why? Because we need to find also the theta. So how do we find the theta? We could actually use the tan function, tan inverse, the 14,285 over 30,423. So let's input it in the calculator. Tan inverse of 14,285 over 30,423. We will be having the value of 25.15. But 25 over 0.15 is only this. This is 25.15. And now we need to also search for this. And we see that this one is actually a right angle. So what if it is a right angle? It is 90 degree. So how do we find the theta? Is actually 25,15 add with 90 degrees. So we will be having the answer of 115,15. And it will be moving in the anti-clockwise. Okay, I think that's it. Thank you guys.
Okay, question number 3. Two particles A and B of masses 2.4 kilograms and 1.2 kilograms respectively are connected by a light and extensible string, which passes over a fixed smooth pulley. A is held at a distance of 2.1 meters above the horizontal plane, and B is 1.5 meters above the plane. The particles hang vertically and are released from rest. In the subsequent motion, A reaches the plane and does not rebound, and B does not reach the pulley. A. Show that the tension in the string before A reaches the plane is 16 newtons, and find the magnitude of the acceleration of the particle before A reaches the plane. So I drew this little diagram right here. We can see that particle A and B are attached to the string over a fixed smooth pulley right here. And because they're attached to the same string, means that both of them have tension, and the tension between them are equal. We also know that the weight is equal to 24 newtons because of the mass, which is equals to 2.4 kilograms. It also applies to B, which the weight is equals to 12 newtons. We also know that A is 2.1 meters above the plane and B is 1.5 meters above the plane. So how can we find the tension from this diagram right here? So we can use Newton's second law, which is F is equals to ma. So for the particle A, it is t minus 24 is equals to negative 2.4a. Now, as you notice, the mass is negative. Why is that? Because if you see from this diagram, the mass of particle A is greater than the mass of particle B. Now, because the mass is heavier, it means that the mass will be going downwards, of course. Hence why the mass is negative. So for the particle B, it's just t minus 12 is equals to 1.2a. Now we can just subtract both of them. And we can get that negative 12 is equals to negative 3.6a. Now that we can get this, we can also try to find a. So a is equals to 10 over 3 meter per second square. But you can also write 3.33. It's based on your preference. Now from this, we can try to substitute the a in any of these equations from particle A or B to find the tension. So I'm gonna choose the particle B. So t minus 12 is equals to 1.2 times 10 over 3. T minus 12 is equals to 4. Hence, the tension is equals to 16 newtons. Shown. And that's it on how to find part A. Alright, moving on to part B. Find the greatest height of B above the plane. So we're asked to find this height right here, right? So how can we do that? You know that from this statement right here, the subsequent motion A reaches the plane and does not rebound. Meaning that as the A reaches the plane or goes down, it doesn't go bounce up again. And B does not reach the pulley. So from that statement, we can conclude that the final speed for both the particles are the same. So how can we find that? Firstly, we can write particle A first. We know that from part A, the acceleration is equals to 10 over 3 meter per second square. We also know that the S for particle A is 2.1 meters. And we also know that because it's released from rest, the U is equals to 0. So to find the final speed, we can use the kinematics formula. V square is equals to U square plus 2AS. So V square is equals to 0 square plus 2 times 10 over 3 times 2.1. And we can get the final speed as square root of 14 meters per second. Now we're not done with that because we haven't found the greatest height yet, of course. So to find the greatest height, particle B, we can use the kinetic energy of mv squared. mv squared is equals to mgh, which is the potential energy. Now we can just write half times the mass of particle B, which is 1.2, times the final speed, which is the same as particle A, so square root 14 squared. It's equals to 1.2 times 10h. Now the reason the 10 is positive because it's going upwards, so yeah. So this will equals to 8.4 equals 12h. And we can get the h equals to 0.7 meters. Now this is not the greatest height yet because of course this doesn't make sense if this is 0.7 meters. So to find that, we can conclude that the greatest height is equals 2.1 plus 1.5 plus the previous height 0.7, and the final answer would be 4.3 meters. And there you go. That concludes number 3.
Question number 4. A particle A moving along a straight horizontal track with constant speed 8 meters per second passes a fixed point O. 4 seconds later, Another particle B passes O moving along a parallel track in the same direction as A. Particle B has speed 20 meters per second when it passes O and has a constant deceleration of 2 meters per second squared. B comes to rest when it returns to O. The question is, find expressions in terms of t for the displacement from O of each particle t seconds after B passes O. Okay, so I think it would be nice to draw a diagram here, so let's do that. Here is the track and point O has been marked. Particle A passes point O at the speed of 8 meters per second and continues to move at that speed for the whole track, right? It's moving at a constant speed of 8 meters per second. Then 4 seconds later, another particle B passes O. Okay, so 4 seconds after this, which means A has already moved for 4 seconds, right? So it's all the way over here. 4 seconds later, another particle B passes O. So B would be at O at this instant. And particle B has a speed of 20 meters per second when it passes O and has a constant deceleration of 2 meters per second squared. So it's not moving at a constant speed. So the question is asking us to find an expression that will give us the displacement of each particle t seconds after B passes O. So from this instant, for the rest of its motion, what is the displacement of the particle? Okay, so initially then particle A would have a displacement of 8 times 4 because it's already moved for 4 seconds, right? That's when the quote-unquote timer starts. It's already moved for 4 seconds, so it has an initial displacement of 8 times 4, which is equal to 32. And the expression for A would just be 32 plus any additional distance it moves. So 8 times t. That would be 32 plus 8t for the expression of A. And for the displacement of B, so as I've said previously, it's not moving at a constant speed, right? So we would have to utilize a Suvat equation, and the equation for that would be ubt plus half at squared. Substituting in the values of ub equals to 20. 20t plus half times negative 2. Remember, it's decelerating, so acceleration is negative. And multiplied by t squared. Okay, so simplifying that will give us the expression of 20t minus t squared. And that is our answer for part A. Okay, for part B, find the values of t when the particles are the same distance from O. So when the particles are at the same distance, that means SA equals to SB, and we can just simply equate the expressions we obtained from part A, right? So that would be 32 plus 8t equals to 20t minus t squared. And we can move everything to the left-hand side. So we would get t squared minus 12t plus 32. And as you can see, we obtain a quadratic expression. And we have many ways of solving this, but I think it would be easy to just factorize it. Factorizing it gives t minus 4 times t minus 8 equals to 0. And our answers would be t equals 4 seconds and t equals to 8 seconds. And that is our answer for part B. Now on to part C. On the given axes, sketch the displacement time graphs for both particles for values of t from 0 to 20. Okay, so from the expressions obtained in part A, we have SA is equal to 32 plus 8t, and SB is equal to 20t minus t squared. So we can recognize that SA is a linear equation, while SB is a quadratic. Let's do SA first. So if we want to draw a linear straight line, right? For this case, we can just simply find the value at t equals to 0, the value at t equals to 20, and then just draw a straight line from 0 to 20, right? So at t equals to 0, SA is equal to 32, and at t equals to 20, SA is equal to 32 plus 8 times 20, which is equal to 192. So plotting the 2 points and drawing a line connecting them, we have the graph for SA. Now for SB, it's a little bit more complicated because SB is a quadratic, right? So we have two things we need to consider when drawing a parabola, which are the turning points and the x-intercepts. First, calculating the turning point, we have to utilize the complete the square method. So we can first group the expressions into a bracket and complete the square. We add a term inside the bracket so that it can be turned into a complete square. And then we subtract the term outside of the bracket. And this gives us the expression of negative t minus 10 squared plus 100. Right? I hope you still remember how to do complete the square. And so the turning point would be 10, 100, which aligns very nicely in the graph. Now for the x-intercept, we just simply equate the expression to 0. Factorizing it gives t times 20 minus t equals to 0, and so the x-intercepts are at t equals to 0 and t equals to 20, which is also very nice for the graph, as it's the starting and end point. So drawing the graph, right, this is the turning point of the graph, and we draw a upside down U connecting from t equals to 0 and t equals to 20, passing through the turning point. And we have to mark that as SB, and there you go. This is the graphs for A and B. And this is our answer for part C.
Hello everyone, welcome back with me, and I will be now discussing question number 5. A block of mass 12 kg is placed on a plane which is inclined at an angle of 24 degrees to the horizontal. A like string making an angle of 36 degrees above a line of greatest slope is attached to the block. The tension in the string is 65 Newton. The coefficient of friction between the block and the plane is mu. The block is in limiting equilibrium and is on the point of sliding up the plane. So when we first read the question, we also need to analyze the question. Like for example, I have found a key point here. It is told that it was equilibrium. So what happened if it's equilibrium? It means there will be no acceleration. So actually, this question, we could use our past formula, the one that I discussed in number 2, which is EFX is equal to ma. But since the acceleration is 0, so the ma would be 0. Okay, now let's manipulate the picture with the data given. First, we have the mass. So this one would be the weight. So what is weight? It is actually mass times gravity. So the weight would be 120. And also here we have Wy. So it is weight in y directions. So it would be 100 cos 24. Why cos? Because adjacent and we are given adjacent and hypotenuse. So what trigonometry we will be using if we have adjacent and hypotenuse? It would be cos, right? So we will be using 120 cos 24. And also we have the W in the x direction, which was 120 sine 24. Okay, now for the next one, we have this 65 in the x direction. It is x65. This one is adjacent and this one is hypotenuse. So 65 cos 36. And we also have in the y direction, which was 65 sine 36. And also, it is mentioned in the question that we will be having friction. So there will be friction here. If we have friction, we will also be having normal force. Why? Because friction force is equal to mu times normal force. Okay, now let's jump into the equations. Now first let's calculate the sum of the x direction first. So 120 sine 24 addition with friction force minus this one it would be 65 cos 36 is equal to 0. Okay, now we could skip this one for a second, and we could actually find the EFY first, because maybe in the EFY we would be given the things that we need to find in the EFX. So in the EFY, we will be having the 65 sine 36 addition with n, and minus the wy, which is 120 cos 24 is equal to 0. Now, we have found the n value here. So if we calculate it using our calculator, we will get the normal force value. 120 cos 24 minus 65 sine 36. Okay, so we got the value of the normal force is actually 71,42. So guys, what should we do now? We will be using this formula again. Why? Because we have friction force. And as I explained before, friction force is equal to mu times Newton. And now we need to find the mu. So 120 sine 24 plus 71,42 times mu minus 65 cos 36 is equal to 0. So let's actually calculate the 65 cos 36 minus 120 sine 24. 65 cos 36 minus 120 sine 24. The value is actually 3.7777. Wow, 777. It is a lucky number, isn't it? This one. Okay, now let's continue our calculation. Let's find the value of the mu. So the value of mu would be 3,7777 divided by 71,42, which we would get the value of 0.053. And this is the value for number 5. And I think that's it for number 5. Thank you guys.
Okay, moving on to question number 6. A car of mass 900 kilograms is moving up a hill inclined at sine inverse 0.12 to the horizontal. The initial speed of the car is 11 meters per second. After 12 seconds, the car has traveled 150 meters up the hill and has speed 60 meters per second. The engine of the car is working at a constant rate of 24 kilowatts. Part A. Find the work done against the resistive forces during the 12 seconds. Again, I drew this little diagram right here to show the car moving up the hill. So from this statement right here, we know that the initial speed is 11 meters per second. And once it reaches the top of the hill, we know that the speed changes to 60 meters per second, which makes it the final speed. Now, we also know that it is inclined at the sine inverse 0.12 to the horizontal. So we need to find the height of this first. So how do we do that? So first of all, because the sine inverse is 0.12, we need that sine theta is equals to 0.12. And we also know that sine usually means it's opposite over hypotenuse. So in this case, it's h over 150. So from these statements, we can get h over 150 is equals to 0.12. Meaning that the h is equals to 18 meters, if you calculate it. Okay. Now, we also know that the power of the engine of the car is 24 kilowatts, meaning that P, if you convert it, it's 24,000 watts. Now, from this, we can also get the work done by the driving force. Using the formula P is equals to work done by driving force over the time. Now, we can also rearrange the equation, so we become work done by driving force equals P times T, which will equals to 24,000 watts, times 12 seconds, which will be equals to 288,000 joules. Okay, moving on. So we're asked to find the work done against the resistive forces during 12 seconds. So in order to do that, we can use the energy method, which is WDF minus WDR, which is what we're trying to find, equals to the change in potential energy plus the change in kinetic energy. So we know that WDF is 288,000 minus WDR is equals to mgh plus half m v square minus c square. So for the potential energy, the mass of the car, which is 900, times 10 since it's moving upwards, times the height, which is 18, which is what we found just now, plus half times 900 times the final speed, which is 16 squared, minus 11 squared, the initial speed. You just write the values on the left first. Okay, now we can just calculate the formula on the right, which will be equals to 222,750 joules. Now we can move the work done by the driving force to the right, so it will be equal to negative 65,250 joules. Concluding that the work done against the resistive forces is equals to 65,250 joules. And that's it for part A. Moving on to question number 6, part B. The car travels along a straight horizontal road. There's a resistance to the motion of the car, 1,520 plus 4 V newtons, when the speed of the car is V meter per second. The car then travels at a constant speed with the engine working at a constant rate of 32 kilowatts. So the car now travels at a straight horizontal road. And now we have to find the FD since it's not mentioned here. And we already know that the resistance force is equals to 1,520 plus 4V. So how can we find the driving force? Or first of all, we know that P is equals to 32 kilowatts, which if we convert it, it's equals to 32,000 watts. Now from this, we can actually find the driving force by using the formula P equals driving force times the V. Now if we arrange this, we can get FD is equals to P over V, which is equals to 32,000 watts over V, since we're trying to find that. Now it also mentions that the car is traveling at a constant speed. Now when we say constant speed, it means that the resultant force of the car is equal to 0, meaning that we can use sigma F is equals to 0, meaning that the driving force minus the resistive force Fr is equal to 0. So now we can just input the values 32,000 over V minus 1,520 plus 4V equals to 0. Now we can move the resistive force to the right, so it's going to be 32,000 over V equals to 1,520 plus 4V. Okay, now to get rid of the V in this one, we can just multiply this by V. So this will cancel out, meaning that 32,000 will now equal to 1,520 V plus 4V squared. And we can also divide this by 4 too. So the one on the right will become 8,000, which will equals to 380 plus V squared. Now rearranging this, we can get V squared plus 380 minus 8,000 equals to 0. Now we can now use the formula V equals negative B plus minus square root B squared minus 4AC, over 2A. Now we just input the values. The B is negative 380 plus minus square root 380 squared negative 4 times 1 times negative 8,000 over 2 times 1, which is just 2. So now we can just make it equals to negative 380 plus minus 420 over 2. So now we can get both of the values of V. So V is either equals negative 380 plus 420 over 2, or V is equals to negative 380 minus 420 over 2. So this one we can get equals to 20 meter per second. And this one is equals to negative 400. But the thing is, the final speed cannot be equal a negative sign. So we can just cancel this. And now we can conclude that the final answer is equals to 20 meters per second. And that concludes for question number 6, part B. For the last question, question number 7. A particle P moves in a straight line. The velocity v meters per second at time t seconds is given by these equations. Part A, show that there is an instantaneous change in the acceleration of the particle at t equals 10. So what we need to show is that the acceleration using the first equation at time t equals 10 is going to be different to the acceleration at time t equals 10 using the second equation. And we know that acceleration is dv over dt, right? So using the first equation, differentiating 0.5t will just give us 0.5. And when t equals 10, a is still 0.5. Okay, now using the second equation from t equals 10 to t equals 20, differentiating the expression to get us the acceleration will give us 0.50t minus 8. Now plugging in t equals 10, a is equal to negative 3. And that's it. So we already showed that using the first equation, a is 0.5, but using the second equation, a is negative 3 at time t equals 10 seconds. Okay, finally, part B. Find the total distance covered by P in the interval t greater than 0 and less than 20. Okay, from the given expressions for V, it's very tempting to just integrate for the first equation from 0 to 10, and then add the integral from 10 to 20 for the second expression, right? But that is actually wrong. And we'll find out why. So the first equation is linear and the second equation is quadratic, right? Linear is very straightforward, but for the quadratic, let's find the turning point and the x-intercepts. So we can find the turning point by using complete the square, right? We find out that the turning point is 16, negative 4, and the turning point is actually below the x-axis. So when we integrate below the x-axis, it actually gives us a negative value. And okay, so for the x-intercepts, we equate the expression to 0, and then we can just use our calculator to factorize, or if you can factorize manually, that's okay also. We get the value of t equals to 12 and t equals to 20. And graphing the two equations given to us, it would look something like this. So we actually have to find the integral of 3 different parts. And as you can see, if we were to do it with just 2 integrals, for one from 0 to 10 and then the other one from 10 to 20, it would subtract the negative part of the graph. But we don't want that because it's asking us the total distance covered. Now now we can calculate the integrals. For area 1, it's just the integral of 0.5t from 0 to 10. I'm assuming you already know how to integrate, and we can just substitute in the limits from 10 and then minus substituting in the limits from 0. This gives us 25, right? And for the second area, it's 0.25t squared minus 8t plus 60 from the limits 10 to 12. This gives us the value of 14 over 3. Now for the third area, we use the same equation but use the limits from 12 to 20. And we get the answer to be negative 64 over 3, which is expected because this part of the graph is below the x-axis. Now for the total displacement, it would be the sum of all the absolute values of the displacements calculated. So 25 plus 14 over 3 plus the absolute value of negative 64 over 3, which is just plus 64 over 3. And that turns out to be 51. So the answer for this final part is 51 meters. And that's it.